Oh, you guys can now say hello to Abla.
I love you.
That's okay.
I love you.
All right, here we go. All right, this lecture today is a review on complex numbers.
My house again. Dude, what's wrong with you? I'm upset.
Review on complex.
Oh.
All right, so let's get started, shall we? First, let's build all of the number systems. So remember what they are. Our very smallest little number system are those lovely little natural numbers. All right, 0, 1, 2, 3, et cetera, et cetera. We go up higher than that. We go to the rational numbers. So this has a notation of n for natural numbers. Rational numbers uses Q for quotient group. And, oh, I'm sorry, I forgot the integers before that. Integers is Z, and that is from the German word for integers. It starts with a Z. And the integers are the negative and positive natural numbers. So all of these and then all the negative ones. Okay, so all of that, it will come up in a minute, it's just lagging. So all of the negative ones and the positive ones make up the integers. Right? Then you have the quotient group. Those are all of the rational numbers. And it seems to be struggling mirroring, so I'm going to try again. All right, so this is the quotient group. Rational numbers, that's all the fractions. Any fraction or whole number you can make. If it can be written as a fraction, any quotient of two whole numbers. So that's like 0 because it can be written as 0/1 and 1 and 2. So all of these numbers are in it, but also 1/2 is in it, and 3/2 and 4/5 and 118/123 and the negative versions of everything. So any quotient, any fraction. Right? Up to this point, all of these are called countable. Even though they're infinite, we can count them. They're not that big. They're big, they're infinite, but they're not that big, we can count them. There's a way that we can label them that will never miss a single number. Right? Then we hop up to what we call real numbers. The real numbers are the rational numbers and the irrational numbers. Real numbers, we use a double bar R, and you have all the irrational numbers out here. These are fractions that don't terminate, like decimals that go on and on and on forever, never repeat, never terminate. They are numbers like pi and the square root of 2 and the square root of 3 and the square root of 17 and negative square root of 3 and so on, like all of those.
11.
Right? And the square root of 11 and e. And the funny thing about irrational numbers, it seems like there's a lot fewer than these, but there are infinitely more of these. So these are uncountable. There are so many that we can't count them, right? So altogether, you get the real numbers, and that's what makes the real number line. But then there's a whole group of numbers that we tag on to this. And those are what happens when you try to square root a negative. Right? So any square root of a negative number, any square root of any negative number becomes an imaginary number. And it's any square root of a negative number. So the square root of negative 12 and the square root of negative 13 and the square root of negative 11 and the square root of negative 2 and so on. All of these are imaginary numbers. And you combine these two numbers together, these two systems together, and you end up combining these two systems together, the reals and the imaginaries, and you add and subtract them, multiply and divide them, and you get a number system called the complex numbers. And you usually write a complex number as a double bar C. So, that's ugly, that. All right. So you have the reals, the quotients, the integers, the naturals, and the complex numbers. A complex number has two parts. It has a real part. Usually we write it with the variable a plus an imaginary part. B is a real coefficient in front of I, which is the imaginary number. Okay. So I, that's part, sorry. So I is equal to the square root of negative 1. Right. That is the imaginary number. I is equal to the square root of negative 1. Right, when we're simplifying things that have square roots and negatives, we always take the square root of out before you take the negative out, right? So let's take, for example, let's take the square root of negative 200. Right? We take the negative out first. This is undefined in the real plane. Like there's no point on the number line for this piece. Once we take the negative out, now this number is on the real line, right? I could rewrite this as 10 root 2 I, and that's the most simple form in terms of exact math.
Does
Right?
the I have to go at the very end of the?
Typically, yes, but this would, as long as you could put it in front, it commutes. So it doesn't really matter, although convention would say that you would put it at the end, right? You would make sure it's not underneath the square root. You always have to take care of the negative before you do any simplification of it, right? So let's take this common kind of mistake, right? Oh, that's the same as the square root of 16, because, multiply it together, boom, square root of 16. This is a common mistake. Don't do this. The square root of 16, oh, that's 4. That's not true. That's not how that works, right? You have to take care of before you do any type of manipulation with the square root of a negative number, you have to take the I out first. So what is better to say is this is the square root of 4i times the square root of 4i. Once I get those i's out, now I can manipulate those numbers. That's the square root of 16 I squared, which is 4i squared. I'll talk about I squared in a minute.
Isn't I squared negative 1? Yeah.
It is. So I squared is negative 1, so this would be 4 times negative 1, which is negative 4.
So I squared is literally just negative 4?
No, I squared is equal to negative 1.
4i squared is negative 4.
Yes, 4i squared is negative 4.
Alright.
Yep. And doesn't that make sense? Because what is this right here? This is the square root of negative 4 squared. So that would cancel those out, and you should just get negative 4. So that makes sense, All right, so you always have to take care of that negative first before you simplify. Next up. All right, now, let's just look at multiples of I. We know I is equal to the square root of negative 1. This is by definition. All right, now we're going to just do some multiples of I and see what happens. If I take I squared, which is I times I, which is the square root of negative 1 times the square root of negative 1. Right? That's just going to be the square root of negative 1 squared,
So that's just me.
negative 1. Just like we did that negative 4 before, this is just negative 1. So I squared is negative 1. I cubed is I times I squared. That's just laws of exponents. But I squared is negative 1, so this is I times negative 1. So this is just negative I. Okay? And let's walk through that one more time. I cubed is really having struggle with this whole idea of being real or not.
It's not real.
It's not real.
Oh, is a square root real?
Yeah.
Why?
Yeah, because it'll equal a number.
Well, this equals a number 2.
No,
Yeah, but it's an imaginary number. It's a fake
Only
number.
because we call it an imaginary number. I could have called it a Jacob's number,
Okay.
and
Even Jacob's not real either.
then you'd be like, oh, it's a Jacob's number. This guy Jacob, he's crazy, but okay. I like. If I take I cubed, all right, let's pretend like it's not I. Anyway, we'll just keep moving this around. I think of I all the time. Me, 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 me. Let's go shopping for who? For I.
I agree with that.
Yeah. Okay, so
I'm the fourth as well, so.
we're going to take I squared times I. This guy is equal to negative 1, so we end up with negative I. Now I'm going to do I to the 4th. All right, if I break down I to the 4th is the same as what?
-1 times -1.
Right, because it's I squared times I squared, which is the same as negative 1 times negative 1, which is just 1.
This
So-
is like not okay.
You can do it. All right, if I look at I to the 5th,
It always equals I.
Negative 2I.
you're right, it just equals I. Well done. Because I to the 4th, times I to the 1st. And that's I to the 5th.
-1 times -1.
So this is just 1 times I, which is just I.
Period.
Yep. I to the 6th. That's the same as I cubed times I cubed. Okay. I cubed is negative I times negative I.
This is I.
A negative and negative make a positive, so this is the same as I squared.
Hold on, you're telling me,
And then that's just negative 1.
you're telling me that the,
So it just repeats.
you're telling me I to the 5th and I to
Boom.
the 6th equal the
Well
same.
done. It just repels. Yes, it repeats. So it's going to repeat every 4 times.
This Jacob is crazy.
Is it fair to say that x cubed is the same as x times x squared?
Yes.
No problem there, right? Right. Now what if I told you that x squared equals negative 1?
Never mind.
Couldn't we just substitute that in for that? And that's fair. And this would just be negative x.
But that's real.
Why?
That isn't real.
That's not real because X isn't a number. A miss.
Yeah, but you can make
Letters are not numbers, so therefore it does not matter. I'm not gonna go anywhere and think of I.
I know this Jacob guy, he really. All right, so it starts like, it goes I, then it goes negative 1, then it goes negative I, and then 1. So this is I to the 1st, I to the 2nd, I to the 3rd, I to the 4th. And then it repeats. I to the 5th is just I. I to the 6th is just negative I. I to the 7th is negative I. I to the 8th is 1. All right? And then we repeat again. So using this pattern of repeating, what if I wanted to know what I to the 211th is? I'm not going to count to 211.
It's I.
I'm going to divide by 4, 211 divided by 4 goes in 5 times 20. 11 goes in 2 times 8. And my remainder is 3. So this is the same as I to the third, because my remainder is 3. So this is going to be the same as negative I.
Told you.
All right. What is I to the 57?
Negative I.
Let's find out. 57 divided by 4 goes in 1 time. 4 minus 1 is 17. Goes in 4 times. 16 has a remainder of 1. This is the same as I to the first, which is just I.
Told you.
All right. All right. Let's try again. Let's do this until we get just this part down. I to the 83. 83.
So it's,
right.
oh, it's 3. I do the third.
It's negative
It's
I.
same as I to the third, which is negative I. Nicely done. How did you know that? How did you know it was negative? It was 3.
Because it's on.
No, close though. All right.
I hate you 4 times.
I divided it by 4, and what's the remainder from 83 when you divide by 4? 3. Because, right, 83 divided by 4 goes in 20 times with 3 left over. So you have a remainder 3. It's the remainder that goes up here. Right. Let's try again. Are you ready for this one? This is my favorite one actually. I to the 100.
The remainder is nothing.
Good. What's I to the 0?
0. 1.
1. Thank you. Anything to the 0 power, even I is 1.
Shoot it, though.
I can't count 3.
Okay? Anything goes in, right? Anything that has a remainder 0 is I to the 0, so that is 1. It's the same as, like, remainder 4 out of 4 is 0, right? So, all right, so let's do another one. I to the 105.
5 is usually the remainder.
Is it just I?
5, when I divide by 4, is the remainder?
Is it just I?
You're divided by 4.
What? Because this cycle repeats every 4 times.
It's just gonna be I.
It's I.
Good.
I is the remainder.
It's going to have a remainder of 1,
I see. So I is
and I to the first power is just I.
Because 100 doesn't have a remainder.
Wait.
So if you do 104
How do you
minus
know
105, you get
How do I know it's a remainder of 1?
Yeah.
So I take 105 divided by 4. This goes in 2 times 8. 25 goes in 6 times, right? 24 with a remainder of 1. 4 doesn't go into 1. So that's a remainder of 1.
Okay.
So the remainder goes here. And I to the first power is just I. So these are the ones that you have to have written down in your notes. I to the 0 is 1. I to the 1 is I. I squared is negative 1. And I cubed is minus I. Okay. Those are the 4 you need to memorize, have in your notes, tattoo on your arm, whatever you decide to do. A nice knit tattoo, that's really classy.
I was
Want a
thinking
job?
Yeah, when they see something geeky like this, they're like, yeah, you're hired.
No.
It's when you have like beautiful skulls and roses and stuff, they're like, no, no, no. But if you put something really geeky on your neck, I don't know, I'm feeling like that's going to be a plus.
Like some people do like tattoos with teardrops.
Oh, do you know where that comes
Do
from?
you know what that
I
stands
don't
for?
know. No,
Yeah. Yeah, it's
Means
a,
you killed somebody.
Oh, I didn't know that.
Yeah.
Every teardrop is how many people you killed.
I did not know that.
yeah,
I
yeah.
get 10.
All right.
No idea.
So why would it not?
I hate until I get
All right, so we're going to go, what I did 302. All right. So here we go.
Wait.
Yes.
10 divided by 4 is going to be a remainder of 2, and I squared is negative 1.
All right, so let's say I want to do this on my calculator because I don't want to do the long division. Let's work that out, okay? So on my calculator, I'm going to go 302 divided by 4.
75.5.
And that-
75 times 300.
So we go 302 divided by 4 is 75.5. Now, a shortcut for doing the remainder on your calculator is subtract out the whole number. So you're left with just 0.5. So minus the 75. And you have just the 0.5 left, and then times that by 4. And that will give you your remainder. Right? So this is the same as I squared. And what does I squared equal?
-1.
Yay, good job.
It's not either one.
That's a -1. All right, this is the super important part that you need to memorize. All right, Elisha, walk us through I to the 52.
Yes.
Yes.
Divided by 4,
Okay.
which remainder's just gonna be 0.
Okay.
Good job.
And then that means that it's 1.
Good. Excellent. All right. All right. Any other questions on this part? All right. The only other thing we're going to do today is add and subtract complex numbers. We're not going to multiply them yet until tomorrow. Okay? Just add and subtract them. So, easiest things works like this. Let's do this. 3 plus 2i. Here's a complex number. I want to add it to this one. -4 plus 6i. How do I do that? I do it exactly like I would do anything with variables in algebra. I just add like terms.
Yes.
So,
3 plus -4.
3 plus -4 is?
-4.
Good. And now, these like terms are?
8. I squared.
Not I squared. We're just adding them just like you would in algebra. You're just counting the number of i's. We're not multiplying. We're just adding them just like that. Yeah, I know. You two are mean to each other. All right.
What she said to me in the morning?
All I know is that you're kind of mean to each other. I'm just filtering that out so we can focus on the mouth.
Idiot.
Avila, do you hear what I have to put up with while you're gone? There's so much bickering. All right, here we go. Let's do a subtraction. So let's take, I say 1/2 plus 3i minus 2 minus 4i. All right, I'm subtracting these two numbers. Just like algebra, I collect like terms, but I have to distribute that negative because I am subtracting a binomial. So it'd be -1.5 plus 7i.
Oh, it's a negative. I did this with -2.
Yep.
Can you shut
All right. So how this works is,
I'm sorry.
That's not good for building thinking. I'm trying to focus.
shh, guys. All right. You have 1/2 minus this 2. That gives you the -1.5. And then you're going to take 3 minus a -4. 3 minus a -4 is 3 plus 4, so it's 7i. So you could distribute it out. 1/2 plus 3i minus 2 plus 4i. Collect like terms. 1/2 minus 2 plus 3i plus 4i.
Why is your voice got shaky?
I know, I gleeked on myself. Also known as spit. I spit on myself. So there you have it.
Josie's having trouble thinking.
I know. Plus 7i, just like that. All right, so do you think you guys can reduce these big guys?
No.
Yeah.
And add and subtract. That's your homework tonight. All right, I'm gonna go open your homework and you're good to go, and I'm gonna export this video and post it on Canvas.